The James Webb Space Telescope is the successor to the brilliantly successful Hubble telescope. From a so-called halo orbit about the L2 Lagrange point of the Earth and Sun, its giant gold-plated mirrors capture photons emanating from deep space. This week, the Webb telescope released this image of the most distant star ever observed. Can you tell which one it is? Good luck, it's not obvious. The blue star in the center must be much too close to appear so bright in the image. There are a multitude of galaxies in this shot: oblong disks, swirling spirals, and fuzzy glows. Rule them out. Here's a better hint. Look for gravitational lensing. When we zoom in on the region here, you can see a ring-like shape. If you can picture how light bends through a cup of water or a pair of eyeglasses on a table under direct sunlight, and the distorted rings and shapes that it produces, this is gravity doing something very similar. Light from a distant star is refracted or bent around a massive cluster of galaxies that lie directly between us and that star, like it is bent by traveling through glass. Only this bend is caused by curvature of space-time itself. By sheer luck, the light radiating outward from the star, refracted by the massive cluster, is bent back towards us and happens to be focused together near the telescope. The lensing effect magnifies the star by a factor of 4,000, allowing the telescope to see it despite its vast remoteness from Earth. The star itself is called Arendelle, which might mean something to elves or other fans of J.R.R. Tolkien novels, and the light we're seeing from it appears to be 14 billion years old. How do we know that? Well, the light from the star comes to us redshifted, that is, stretched out from the expansion of the entire universe. Fun fact, the Hubble telescope was named after Edwin Hubble, the man who discovered that the universe was expanding. The light waves from Arendelle have been redshifted so deeply that they are now stretched to 6.2 times their original wavelength. That's the distance from one peak to the next. Long ago, when they were emitted, these waves were visible to the human eye. Now, their wavelength is in the infrared spectrum, invisible to us, but not the special instruments aboard the Space Telescope. Its gold mirrors are near-perfect infrared reflectors, gathering and shining it into infrared cameras. The cameras use mercury, cadmium, and telluride to capture wavelengths long enough to pass straight through the silicon in typical camera sensors. Based on the infrared wavelength of the light in this image, astronomers can calculate that we're just now seeing Arendelle as it was when the universe was a mere billion years old. What's even more astounding is that the star is now 28 billion light-years away from us, and getting farther every day. Objects this distant can never be reached under the laws of physics as we know them. They've receded beyond something called the Hubble Length. Now, Edwin Hubble didn't just discover that space-time was expanding, but that the farther away you looked, the faster it appeared to expand. Most objects in space appear to recede from us with a velocity of about 2 centimeters per second times their distance in light years. In freedom units, an object 1,000 light years distant recedes at about 50 miles per hour. An object 1 million light years away recedes at 50,000 miles per hour. At 14.4 billion light years away, things recede from us at the speed of light. That's the current Hubble length. A ray of light or even a spacecraft moving at light speed launched from our current location in space-time could never reach objects beyond the Hubble length, like Arendelle, and nothing leaving Arendelle today could ever reach us. It's gone. And that's what the Webb telescope saw this week. I hope you found this video informative. Please stay tuned for more upcoming videos on interesting aspects of space, science, and technology. Have a good one.